In this video, I'm going to review how to perform hypothesis testing with p-values, and doing so within the Google Sheets environment. So just like the previous video where we were doing hypothesis testing with confidence intervals, we're going to want to construct our null and alternative hypotheses. Now, in this section, we talk about two different types of tests, a two-sided test versus a one-sided test. Generally, when you're performing statistics, you're going to want to be working on, or generally you're going to be using just a two-sided test. There's very few cases where you end up doing a one-sided test, but usually most statistical books will talk about both, so you're familiar with both. So if we look at the two different types of hypotheses that we form, in a two-sided test, you basically say um, um, the null hypothesis is equal to a specific value, and the alternative hypothesis is equal to any value but that specific value. In this case, in a one-sided test, you are saying that your null hypothesis is basically any value less than any specific value, like 37, and your alternative hypothesis is in a specific direction, and that it's above a specific that same value. Whoops, didn't mean to move that. So in this case, a one-sided test, we're saying that the null hypothesis is less than 37, and our alternative hypothesis is above 37. So it's a specific direction in terms of being above 37, while in the two-sided test, you're saying, well, I don't know which direction it's going to be on. It could be above or below. So generally, we're going to want to do two-sided tests. There's very few scenarios where you have a specific hypothesis in, in, in mind. So after you've constructed your hypothesis, you want to determine your specific alpha level. This is the cutoff for making your statistical decision of whether you're going to reject or retain the null hypothesis. So generally, an alpha, like a convention, is set at 0.05. If you recall, this corresponds to the width of the confidence interval, in that when we were calculating the widths of a confidence interval, let's say we wanted to calculate a 95% width confidence interval. I showed you this in the previous video. We did 1 minus 0.95, and we got a value of 0.05. This value is our alpha value. So that's the relationship between alpha and the confidence intervals. Then you're going to want to calculate a test statistic, a z-score, and in the previous chapter, in the previous module, we showed you how to calculate z-scores. Then what's new is you're going to compute a probability based on the z-score. You're going to use either a table, or more simply, you can use this web page, or this web calculator here, to calculate that probability. And then you're going to make a decision. So if your calculated probability based on the z-score is less than alpha, you're going to reject the null. If your probability is greater than alpha, you're going to retain the null. That's our decision rule that we're going to use. All right, so let's go ahead and just zoom. All right, quit messing around with the zoom. Let's go ahead and go into the Google Sheets environment. So again, we're kind of building off of the previous work that we've done, where first we calculated our standard errors, then we calculated, got our critical Z's, and we calculated 95 and 90% confidence intervals. And then based on this, we these two hypotheses, our null hypothesis and our alternative hypothesis, we had a decision whether to reject or retain the null based on our confidence interval widths. So now what we need to do, which is slightly different, is we need to calculate a test statistic, or an actual z-score, which we've done before already. So we're going to calculate a z-score for each of these for these null hypothesis, in relationship to each one of these variables. So let's just focus on extroversion here. So we want to determine statistically what is the probability that the data that this summary statistic comes from the null distribution. So what we're going to do is we're going to subtract. If we remember what our z-score, let's actually go back to, if we go back a few videos to the formula for our z-score is our population mean, or x, minus, or not x, or our observed mean, x, minus the population mean, or our null hypothesis, divided by our standard deviation, or in this case we're going to use our standard error divided by the standard error to calculate a z-score. So it's slightly different calculation. We're going to actually use the standard error instead of the standard deviation to calculate our test statistic. So we've already calculated our standard error up here. We have our mean. We have our null hypothesis. So when we enter this into the equation, we're going to say equals. To calculate our z-score, we're going to say 56 minus, what is our null hypothesis? 55. We're going to put parentheses around both of these, and then we're going to divide by, we're going to scroll up to our standard error. And so we're going to get a value of 0.77. Let's round that to the hundredth. Remove a couple of those decimal places just for neatness. And so we get 0.77. So now what we need to do is we need to actually calculate a p-value based on this. So we're going to take this value, 0.77, and plug it in to, let's go back to our, we're going to go to, there we go. So here it says P from Z. So we're going to calculate our P, or probability, from our z-score. Remember, our z-score is 0.77. We're going to compute P, and it's going to give us a two-tailed value of 0.443. So we can go back to our table, put that in there. Remember, if we remember correctly, our alpha, or decision rule cutoff, was equal to 0.05. So because our calculated p-value is above this 0.05, we are going to retain the null. And that is the exact same decision that we came up with here with our 95% confidence interval. And we'll see that if we use the alpha of 0.05 and a 95% confidence interval, we'll always get the exact same decision. So let's go ahead and pull. Remember, we can pull our formulas over, and so it'll adjust the calculations relative to where we pull over, and we get two different critical values. We get a negative 2.33 and 1.8. These aren't critical values. Two different z-scores, negative 2.33 and 1.84. So if we look at how this is calculated, we double click on this cell, we can see that 41.73 is subtracted from 46, and we divide that by our standard error, which is 1.83, and we get a z-score of negative 2.33. We can bring this into our p-value calculator. We'll just put in negative 2.33. We'll say compute p, and we get a probability of 0.0198. So let's put that into our Google Sheets, and we see that this is less than 0.05. So we're going to reject the null, or in other words, accept the alternative hypothesis that the population mean is not 46. All right. So finally, for this This last one, 1.84, let's go back over to our calculator. We'll put 1.84 in here. We'll say compute P. We get a p-value of almost below it, 0.0658, but not quite. So we'll put that in here, 0.0658, and that is just above the 0.05, so we're going to retain the null or reject the alternative hypothesis. So pretty simple. It seems like it's complicated. I'm not going to really go into too much more detail with the one-sided test. You can read about that. I think you should use this calculator rather than probability tables. It's a little bit quicker and a little bit cleaner. And it's pretty simple after that. After you've calculated your z-score, which is just the difference between your observed mean minus the null hypothesis mean divided by the standard error, and then you're going to put that z-score into the calculator, and then you're going to get a probability value. If that probability value falls below this alpha value, then you reject the null or accept the alternative. If it falls above that, you're going to retain the null and reject the alternative hypothesis.